Hello, today we come up with a new video. So this new video is about mobile robot path optimization algorithm using genetic technique. So first, in order to go through the code, I would like you to explain what this mobile robot optimization means. Now, mobile robots basically move in environments which can be static or dynamic. And if I talk about static, that means, let's see, in this picture you can see that the environment is static because the starting and the ending points are has been fixed, and the obstacles are fixed on their path also. And the mobile robots are moving from the starting point to the end point on the permissible paths while avoiding the collisions with the obstacles and minimizing the total distance traveled, time taken, or energy consumed. Okay, so here you can see that. So in the dynamic environments, these obstacles has been moved, and the mobile robots has to move from the start point to the end point while avoiding the collisions from the moving obstacles. So that is called dynamic environment. Okay, so our methodology is basically we are using a genetic algorithms. If we talk about genetic algorithm, that means a stochastic evaluationary technique based on the human genetics. Stochastic methods are basically on the laws of probability for sampling of random events and have the advantage that they can handle large problems. Okay, so I explained you static and dynamic environment also. So this is our simulation first simulation file. Before running our simulation file, I would like you to understand we have created a environment first. There is an environment.py file also. In this we have created an environment by defining the workspace to the minimum and maximum of the coordinates, that is which are x and y. There we have defined the obstacles and labeled the path points, defining the starting and ending position also. We have defining the fitness of each chromosome also here, like chromosome lengths and number of chromosome and all. We have created a population file also. Here we are generating a population based on selecting the path points. In this file, we are defining a starting point, considering the each link point, finding the distance from each link point to the end point. We are calculating the probability of moving to each link point and creating a random number, and we are selecting the next point in path. We continue till end point is reached. Okay, now let's run this first simulation file. Okay, let's run it. Pygame window has been opened. I'll explain you what this Pygame window does. Okay, so this is our GUI. We have to randomize the obstacles first. You can see that these are the obstacles. Now we are drawing the starting point and the ending point. Now let's run this program for number of 5 runs, and the generation is 1. Let's start the simulation. Okay, you can see that the cursor has not been moving now. Here you can see that it has run till 5 number of iteration. Now let's draw the optimal path. Okay, so you can see that based on the number of 5 generation, it has uh, find our optimal path. Now if you will increase the number of runs, let's go for 7, and number of generations are 1. let's see let's see 2. And if we start the simulation, see the cursor is moving, still running, is stopped. So let's just draw the optimal path. Okay, so best coast path has been drawn, which is there, it has not changed. If we increase the number of runs, let's say for 6, and start the simulation, you can see that it is running. Stop. Now let's draw the optimal path. Okay, it has not changed. Now let's just see the results. You can see the results. For each number of run, it has generate a path. So this is our mobile report optimization using genetic algorithms. Let's now I will explain you about the pygame window. Let's run the second simulation file. You can see the pygame window has been opened where the obstacles are fixed. Starting and ending point has been fixed. In the number of one generation, it has scattering the obstacles. Then for the two number of generations, what it is doing is it is try to move from the MRS try to move from the starting point to the end point, but it has not reached to the goal point. So for the number of generation 3, it will again try to make this path better. You can see that it has been achieved. So it is just to explain you how this thing work. So in the summary, we can see that we have one optimal solution now to obtain, which is obtained by generating a population of chromosomes and defining the fitness function, then generating the population, and then use the stochastic based generating algorithm. So I hope you find this mobile robot optimization program better. Thank you for watching.